Hi viewers, for this lecture I have come with one more new topic on numerical solutions of ordinary differential equations. It is Milne's method. Before to discuss with this topic, I would like to give some basics, which will be it is single step function. What is single step method? What are the single step methods? What we discussed already, Taylor's, Euler's, improved Euler's, RK method, everything are single step methods only. Taylor's, Euler's, modified Euler's, improved Euler's, and RK method. Everything will be single step method because only one formula, the entire thing will be one formula. Uh, we will use that formula to find the solution for the given ODE, ordinary differential equation. But what about here? Multi-step methods. Now we are going to deal with the multi-step methods. Multi-step methods are two methods are here. Milne's method, what we are going to discuss in this topic, and Adams method. It's not in your syllabus now, right? We'll discuss deeply about Milne's method now. In Milne's predictor and corrector, two formulae will be there. Milne predictor formula. Using predictor formula, we are going to predict the solution or answer, and we will use the predicted one. We will apply that one in the corrector formula. Already we predict the solution. We will apply that solution in the corrector formula to improve the accuracy. That's it. So here two steps. In the first step, that is predictor formula. The first step, we are going to predict the answer or predict the solution. In the second one, corrector formula, we are going to improve the accuracy. That's why we are going to call this as what it is, multi-step methods. Right. And one more important thing here it is, if you want to apply Milne's method, we should know four prior consecutive values. The four consecutive values should be known, not a four consecutive value. Four prior consecutive values should be known to apply in the multi-step methods. What are the multi-step methods here? In your syllabus, you are having only one topic. It is Milne's method. Right. Come to the topic now. To solve, dy by dx is equivalent to f of x comma y. Here, this one also we are trying to solve ordinary differential equations. Right. Given initial and boundary condition, given conditions are y of x naught is equivalent to y naught, y of x1 equivalent to y1, y of x2 equivalent to y2, and y of x3 is equivalent to y3. Right. So as I told you already, four consecutive values should be known. 1, 2, 3, 4. Four value will be there in the question itself. So it should be known to apply the Milne's method, Milne's predictor or corrector method. So what is Milne's predictor formula? Y suffix n plus 1 only here. That comma p we are going to represent to mention this formula is the predictor formula. There is nothing apart from that. Y suffix n plus 1 only should be in the left hand side. For our convenience to mention it is which formula, whether it is predictor or corrector, we are going to represent that capital P here. Right, which is equivalent to yn minus 3 plus 4h upon 3 to yn minus 1 2 dash minus yn minus 1 dash plus 2 yn dash. This is what the predictor formula. Then Milne's corrector formula. Look at that, yn plus 1 comma c. This p and c represents predictor and corrector. For our convenient only we are writing here. If you are not writing that also, it won't be wrong. Right, yn plus 1 comma c is equivalent to yn minus 1 plus h by 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. These two formulae are important to solve the ordinary differential equation problem under Milne's method. Right. I have given one example here. Using Milne's method, find y of 4.4. Given this ODE, here also to confuse you, they have given like that. Only keep the derivative in the left hand side. Take everything to the right hand side. You can get the function. Right. Now come to the point. 1, 2, 3, 4, 5. Yeah. In your textbook, they have given only 4 values. 1, 2, 3, 4. These are all the 4 initial conditions. But additionally, I have included this one here to explain one concept. I will explain that concept later. Just listen now. Now, not only in this one, what we have done in the previous videos also, we have to do the similar thing here. Right. First, we should come to the conclusion, whatever they have given, we have to write it, and what are the requirements, and whatever we have to find, we have to check it. I'm going to do that one only now. X not equal to 4. Look at that. X not equal to 4. I didn't consider this part here. I will tell you why it is later. X naught is 4, Y naught is 1. I have written. Right. Next, X1 is 4.1, Y1 is 1.0049. X2 is 4.2, Y2 is 1.0097. X3 is 4.3, Y3 is 1.0143. X4 is this one. We have to find this value only. X4 is 4.4. What is the value of Y4? That's it. This is what the thing they have given in the question itself. And additionally, they have given one more concept. What it is? We didn't consider this boundary, this initial condition. Why? So what I mentioned earlier, to apply Milne's method, we should know 4 prior consecutive values. What are the prior consecutive values? 1 from the last. Consider this is 1, this is 2, this is 3, this is 4. So 4 prior consecutive values are enough. So to confuse you, additionally, they may give the 5th one also. They're giving the 5th one, omit the first one, whatever it is occurring here. So totally it should be 4. Suppose instead of giving this one, if you are giving all the 4 boundary condition, yeah, you will be in safer side. You have to take all the 4 values for boundary conditions like that: x naught, y naught, x1, y1, x2, y2, x3, y3, and we have to find y4 at the value x4 is 4.4. Directly we can write if they are giving 4 boundary condition. To confuse you, if they are giving 5 boundary conditions, take the last 4. Clear? Take the last 4. That is the clue I would like to give with the help of this problem. Right, come to the problem now. Given differential equation, how to write it? We have to keep a y dash derivative only in the left hand side. So y dash equivalent to, 5x y dash plus y square equal to 2. I have to find 5x into y dash equivalent to 2 minus y square. I have to find y dash only. Derivative should be in the left hand side. All the value should be in the right hand side. That should be our function. Y dash equivalent to what? 2 minus y square divided by 5 into x. That's it. This is what your function, guys. Directly they have to give, to confuse you, they have given like that. That's it. This is your y dash. I hope you have understand. Right, come to the next part. Milne's predictor formula. Now take predictor formula. Yn plus 1 comma p. If you want, you can write p, or you can leave that also. Is equal to yn minus 3 plus 4h by 3, 2yn minus 2 dash minus yn minus 1 dash plus 2yn dash. So look at that yn. Here yn we are getting, yn dash we are getting. Do not confuse both. Got it? Here dash derivative won't be there. The dash means a derivative, represents derivatives. Right. Now we have to find, what you have to find? Y4 we have to find. To find y4, what I have to give for n equal to, obviously it is 3 we have to give. If we are giving 3 only, 3 plus 1, it will be 4. Then what about right hand side? What will happen if we are giving 3? Here it will be y4, comma p predictor will be there. It will be y suffix 0 plus 4h by 3 into 2 into, give n value 3 we are giving, 3 minus 2 it will be 1. So y1 dash minus 3 if you are giving, it will be y2 dash plus if you are giving n equal to 3, 2 into y3 dash. That's it. Look at that, y1 dash, y2 dash, y2 dash, y3 dash. All are derivatives only. Y dash we have. Y1 dash means like in the Taylor series we have done it. And one more clue I would like to give, in the last, in the fourth unit, in the last topic, Milne's method, and the first topic is Taylor's. In both of that one only, whatever they are giving the differential equation, you will consider that as y dash. But in other types like Euler's, improved Euler's, modified Euler's also there, but it's not in our syllabus. And RK method, everything, we will take the derivative y dash as what will be f of x comma y. That is the another clue I would like to give here, guys. Could you remember? In the Taylor's only, we will take the derivative as y dash, we solved it. Similarly, in Milne's only, we will take the derivative y dash as y dash alone. But in some other type models, we have taken consider that as f of x comma y. That's it. Now, this is the way to write the formula. We have to find y4. Look at that. We have to find y4. Give n equal to 0 there. Right. Sorry, n equal to 3 there. If you are giving like that, you will get this one only. Here it will be y4, y0, y1, y2 dash, y3 dash. There will be the difference between y0 and y1 dash. Dash, if it is there, it will be derivative. Y0 means it is simply a initial condition what they have given there. Right. Now we have to find y1 dash. How to find y1 dash? Any idea, guys? How to find y1 dash? Just listen. What is y dash? This is the given differential equation. Y dash is 2 minus y square divided by 5x. I have to find y1 dash. So what I have to do, give in the suffix, I have to give 1 in the left hand side as well as right hand side. That's it, guys. I hope you have understand. I think so. Clear. Suppose if you want to give y2, give suffix 2 here, suffix 2 in that place, right hand side, in this place, and in this place, and here also. Clear. Right. Come to the part now. Now y1 dash I have to find. So what is y1 dash? In the given differential equation, 2 minus suffix 1. Here also suffix 1 I have given. If I'm giving suffix 1 in the left hand side, give in the right hand side of this equation also. Clear? Right. So substitute the values 2 minus y1 square. What is y1? Y1 is the given one, and from the initial condition. 4 boundary conditions are there. From that one, you are going to choose y1. Y1 value whole square divided by 5 into x1. X1 is 4.1. Look at that. I will explain with the help of this. X1, x1, y1. This value. Similarly, x2, y2, x3, y3. From here only, we are going to consider that values. Right. Substitute that value. You can get y1 dash. Next, y2 dash. Look at that and the equation, given differential equation, I am substituting y suffix 2 here. Y dash will be this, give suffix 2. Now substitute x2 value and y2 value, simplify that, you can get y2 dash. Now find y3, because y3 dash we need. Y3 dash equivalent to, give the suffix value 3 in the differential equation, we can get that answer. So now we found y1 dash, y2 dash, y3 dash, and y0 is the initial condition they have given. Substitute everything in equation 2. This is what equation 2. In this equation, we can get the answer. Simplify everything, we can get the answer. So we have predicted. Just we predict your answer. It is not the exact one. We are not, obviously, we are not finding exact one. Nearer to the exact one, approximate one only we are finding. But as I told you already, Milne's is the multi-step method. From the predictor method, we are going to predict one solution. We will apply that solution in the corrector formula to get the accuracy. Fine. Now come to this one. So this is the solution, predictor solution. Now we have to get the accuracy. Now the Milne corrector formula is yn plus 1, comma c. C represents corrector formula. Yn minus 1, h by 3, yn minus 1 dash, 4yn dash, yn plus 1 dash. So we have to find y4. So we have, obviously we have to give n equal to, what will be? N equal to not 0, n equal to 3. Then only you can get y4. Give n equal to 3. We can get, if you're giving n equal to 3 here, it will be y4. If you're giving n equal to 3 here, it will be y2. 3 here, it will be y2 dash. 3 here, it will be y3 dash. 3 here, it is y4 dash. Look at that, y4 dash, we have to, already we found y2 dash, y3 dash. Am I right? Look at that. Y2 dash already we found. Y3 dash also already we found the answer. Now we have to find y4 dash. Am I right? Y4 dash. Where you have to give in the given differential equation only. Give suffix 4. So y4 dash. What is y4? Just before we found the value, the predictor. Using predictor formula, we found the answer y4. That y4 only this. So we are applying the answer what we found in the predictor formula in the corrector one to get the accuracy. So we are applying here a y4 value. X4 is 4.4. We can get y4 dash value. Substitute in the formula y2 we can choose from the initial condition, and y2 dash already we found, y3 dash already we found, y4 dash just we found. Substitute everything here to get the answer using Milne's corrector formula. So this is the formula. Here we have decreased the accuracy. Using predictor formula, we have to get the solution. We have to apply that solution in the corrector formula to get the, or to get the nearer to the exact. That means what? To reduce the accuracy. That's it, guys. This is the way to solve the ordinary differential equation. Particularly, we used here Milne's predictor formula and the Milne's corrector formula. I hope what I explained in this way, it will be very helpful to understand the concept. If you like this video, share to your friends and subscribe it. Thank you, guys. Thank you for watching.